Yes, ma'am.
Good evening, Uma.
Good evening, ma'am.
Good evening. Good evening. Can you hear me?
Yes, ma'am.
Okay.
Ma'am, shall I start the session?
Yes.
Okay, good evening, ma'am. I am very proud to introduce you as a resource person in this ATAL FDP, ma'am. Dr. N. Shanti received BE degree in Computer Science and Engineering in 1994 and ME degree in Computer Science and Engineering in 2001 from Bharatiyar University, Coimbatore. And she has completed her PhD degree from Periyar University, Salem, in offline handwritten Tamil character recognition in 2009. She has worked as professor and head in the Department of Information Technology, K.S. Rangasamy College of Technology, Tiruchengood, from 1994 to 2013. Professor and Dean in the Department of Computer Science and Engineering at Nanda Engineering College, Erode, from 2013 to 2017. And currently, she is working as a professor in the Department of Computer Science and Engineering at Konga Engineering College, Perundurai. She is also heading the training cell of Konga Engineering College. She has published around 90 papers in the reputed international journals, 65 papers in the national and international conferences, and published 2 books. 13 scholars have completed their research under her guidance and currently supervising 7 research scholars under Anna University, Chennai. She has organized a lot of workshops and seminars sponsored by AICTE, MOES, CSIR, DAITI, DST, NABORD, NCW, NHRC, and DRDO. She has received Outstanding Woman Educator and Scholar Award by NFED. Her current research interest includes image processing, optical character recognition, blockchain, and network security. She is a life member of ISTE and fellow member of IEI. I welcome you, ma'am.
Thank you, Satyasudha.
I hand over the session to you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Once again, good evening to all of you. Really happy to be here as a resource person for this ATAL FDP. I thank Uma Maheshwari for inviting me as a resource person for this workshop. I know it's the time is between 8 to 9:30. It's really a hard time to attend session. So I'll try to make it as simple as possible. And let me share my presentation. Is it visible? Uh, yeah. Thank you. Thank you. Okay, so once again, I welcome all the members for this presentation on components of AR and VR, augmented reality and virtual reality. I'll just go in this way. I'll be, even though I do not know whether the previous session they have handled all this, but just a brief introduction on some introduction to AR, VR, how it works, the difference between AR, VR, what are the elements of AR, VR, and the different components which is used for AR, VR, and that is going to be the topic for today's session. So hardware, software, connectivity and communication, key supporting technologies. So these are the very important components which are used for AR, VR, and some use cases and applications, and then what will be the future of AR, VR. This AR and VR, they are groundbreaking technologies which are revolutionizing how we interact with the world, offering applications across different domains like entertainment, education, healthcare, etc. etc. There are a lot of industries where this application of AR, VR can be used. So let's see about this some introduction, and then we'll move on to this components used for this AR and VR. So first, let's see what is augmented reality and virtual reality. So let's welcome. I welcome all of you for the exploration of this AR and VR. These two are the most powerful technologies which are transforming the way we interact with the world around us. It's a groundbreaking technology which is newly introduced and it's used in different field. So first, let's understand what is augmented reality. If any of you would have seen my background, now I have closed the video. If any of you would have seen the video in my this Google Meet, you would have seen there are some background behind me. Actually, it is not the original background. I have embedded, I have enhanced my picture or some realistic picture, official picture behind me. So that's a kind of an example for augmented reality. So let's say this augmented reality, it overlays the digital information onto the real world, enhancing our perception. So we are enhancing the actual view with some digital information. So if you see here in this picture, a person is looking at his room, living room, where he imagines if all these furnitures are placed in the living room, how it looks like. So here we are putting some images onto the real picture. So we are enhancing the real images. So this we call it as augmented reality. So where we overlays some digital information onto the real world. So it's a mix of both digital and real world information. But if you take virtual reality, it is completely virtual, or the real world presence is very minimal when compared to augmented reality. So VR refers to an artificial immersive environment created with the help of computer technology through sensory stimuli like sight, audio, touch, etc. So here we get immersive experience, and it's also interactive and engaging because we are immerses users in a completely digital environment. So it's entirely different from the real world. So it replaces the real world with a simulated one using the software's computer technology. And it's also interactive and engaging, like in a lot of games. Now this VR technology is used. So users can interact with the virtual objects and environments using some controllers, body movements, creating a truly engaging experience. So we'll all feel like, say for example, if we want to imagine if we are in a dark forest, how it would be surrounding some animals, sounds of birds, etc. Really, we'll be sitting in our living room and imagining that we are in a deep forest. So we'll be feeling all those experience, like you can sometimes feel the sounds of animals, the sound, touching feel. You can touch, even try to touch the woods which are the trees which are available in the forest, like that. So you will have an entirely different kind of experience in virtual reality. But in augmented reality, we are combining both the real world and the virtual world. So when you compare this AR and VR, if you take AR, it enhances the real world with digital information. VR, it creates an entirely digital world replacing the real world. So the amount of presence of real world is very minimal in the virtual reality. So in augmented reality, it augments real life scenarios by enhancing them with digital data, making it useful for interactive guidance and education. Here it is fully immersive and ideal for scenarios requiring complete focus on a virtual environment. So here for AR, we use a device like AR headsets like Microsoft HoloLens or smartphones. Here we need device like VR headsets, example Oculus Rift, HTC Vive, etc. So depends on the requirement, depends on the need, we can go for either augmented reality or virtual reality. So if you say key difference between AR and VR, so here one is perception, another one is device which used for AR and VR, and then interaction, that is how the AR allows interaction and VR. So if you see perception, AR means AR augments the reality, that is it adds something with the real world, while VR completely replaces. In the right side, you can see the difference between virtual reality and augmented reality. Uh, can you all hear me clearly, or any disruptions or something? Okay, thank you.
Clear, ma'am.
So, AR uses smartphones, tablets, or specialized glasses, but VR requires specialized headsets. And AR allows interaction with both real and virtual elements, but VR focuses more on virtual interaction. So if we compare in virtual reality, 75% virtual and 25% real. But if it is augmented reality, where the vice versa, 25% virtual and 75% real. So VR is fully immersive and AR is partially immersive. That we'll see later what it is. Now let's see how this AR VR works, because only if we understand this, we'll understand the need for the different components required for AR and VR. So now let's discover the inner workings of augmented and virtual reality. So if you see how this augmented reality works, as I already told you, this augmented reality, it combines the real world with the virtual world. So we need information related to the real world also when we combine the virtual world. So for that we need sensors and cameras. So AR enabled devices like smartphones, AR glasses, etc. They use sensors and cameras to collect data about the real world, because we need to integrate both real world and the virtual environment. So it captures objects, locations, and depth in the surrounding environment for the real thing. Next step is processing and mapping. So the AR software, it processes the data from the sensors collected from the AR-enabled devices to understand what is the real environment. Say, for example, if it is a living room, then what is actually there in the current environment. So that has to be understood using the data from the sensors. Then it maps the physical world using technologies like SLAM, means simultaneous localization and mapping, to position virtual objects accurately. Because say if we want to see how, if we place some furnitures into the furnitures, TV, etc., into the living room, first we should know what is actually there in the living room. So then only we'll know where to place that furniture, where to place that TV. So for that, we should know the information regarding the real environment. So first we are capturing through sensors and cameras. Then after that, the software process this data which is collected from the sensors to understand what is the current environment. Then it maps the physical world using the technologies like SLAM, so that virtual objects can be positioned accurately. Then next one is projection and display, where once the real objects are placed accurately, then next is AR overlays the digital content, like it overlays images, videos, 3D models, etc., onto the real world view through some mobile screens or AR glasses or headsets. So through these devices, it overlays the digital content onto the real world view. Okay, then next is now both the real world object and the digital content is overlaid. So now the users can interact with this environment through gestures, touch, or voice commands. So example, if we want to resize virtual objects, then we can do using by either by touching the screen or using voice commands, etc. So this is how augmented reality works. So first using the sensors and cameras, it takes the real world data, then it processes this data and then overlays the digital content into the real world. Then we can interact through gesture, touch, or voice commands. So this is how AR works. Next comes the virtual reality. So here, if you see, first, because in virtual reality, almost everything is a virtual environment. But if you take augmented reality, 70% real and only 25% is virtual. So here, first thing what we need to do is creation of a virtual environment. So here, virtual reality system, a VR system, first generates a fully computer simulated environment using game engines like Unity or Unreal Engine. So, say for example, as I already told you, if we want to imagine we are walking in a dark forest, then for that, first we should simulate an environment of a forest. So, forest, then animals, then birds, then sounds. So, all that environment should be simulated using the computer software like Unity or Unreal Engine. So it includes visual, auditory, and sometimes tactile elements. That means you can touch and feel the elements, virtual elements which are created. So all this can be created using a computer simulated environment. Next important device which is used in this VR is head mounted display. So that's one of the most important hardware component which is required. So here devices like Oculus Rift, HTC Vive display the virtual environment to the user. So using this devices, if the user looks into it, they can see the virtual environment. Then the headset lenses are present. They adjust the perspective of the user to create depth and immersion. So once if you wear that head-mounted display and started viewing that virtual environment, you will feel like you have a perspective that you are inside the environment. So recently, one company came for our college and they have given this virtual headset and they have asked us to view the company environment, how the company is functioning, how their main aim is transportation, how different vehicles are coming in, how they are doing all the operations. So we when we sees through that, we could feel that we are in that company environment, how the different things are operating, etc. So without going directly to the company, we could feel the different operations and how different people are working in that. All these things, office, how office looks like, and what are the different operations. Everything we could see from our place itself. So that's the help of this VR environment. The next is motion tracking. So here VR uses sensors to track head movements, body position, and hand gestures. Because once if we start wearing this head-mounted display, and if you see that we'll feel that we are in that environment. So if we move our body, if we touch something, we'll feel that we are in that environment itself. Okay. So here there are some technologies which are used like accelerometers, gyroscopes, and external tracking systems like cameras, infrared sensors, etc. to track the motion in the virtual environment. Then, in addition to that, we use input devices like hand controllers, gloves, motion sensing devices. They allow users to interact with the virtual world. That is, you can try picking up some virtual objects, you can press buttons or moving within the environment, etc. So, for that, we need some input devices. Then rendering and real-time feedback. The VR system processes user inputs and provides real-time visual and auditory feedback. So when a user tries to touch something, then he could have he could feel that he is really touching something. So when the user gives some input, then the system should process this input and provides real-time visual and auditory feedback. So they should hear some noise, something like that. So for that, we need high performance GPUs for smooth rendering and minimize latency. Then audio integration. So again, not only video, audio is also essential. So 3D spatial audio enhances the immersive experience by simulating sound directionality. So sometimes you will feel like some footsteps behind you in the virtual world. Like when you are walking in the forest, you will feel that somebody is coming, some animal is coming behind. So you will be hearing some footsteps. So all these things can be possible with the help of virtual reality. So if you see, you can create, first you have to create a virtual environment using some game engine. Then we need head mounted display. You have to track different motions. Then we need input devices to interact with the virtual environment. Then the VR system gets the user inputs, renders it, and it gives real-time feedback. Then integrating audio with the virtual environment. So this is how virtual reality works. Okay, next comes the different categories of AR, VR, where we explore the different landscape of virtual reality from fully immersive experience to those that bridge the gap between the physical and digital worlds. Like here we'll be seeing the three different types of categories of AR, VR, where fully immersive, partially immersive, and non-immersive. So first is fully immersive. So where here, in the fully immersive, the user will get a complete immersive experience using the headsets and controllers. The users will have complete sensory immersion, and they'll get enhanced realism, realistic visuals, and spatial audio for captivating. That is, the users will have a feeling that they are in the real environment, even though they are completely in the virtual environment. In the fully immersive, like in games and all, people will feel that they are in that environment itself. Okay, so in the fully immersive VR, it offers a complete virtual experience where the user is cut off from the physical world and entirely engaged in a computer generated environment. So that's called fully immersive. So here it requires a VR headset. Then it includes like motion controllers, gloves, and body suits for interaction. And so in this, the VR software tracks head, hand, and sometimes body movements in real time, and it offers high quality graphics and 3D sound for a realistic experience. Some many of you would have seen some 3D movies where we'll wear the glasses, and if we see the movies, then we'll feel that we are inside that environment. So that's something is an example for this fully immersive environment. So examples are like gaming, training simulators, like flight simulators, medical surgeries, etc. Then virtual tours, real estate, museums, even some colleges they have virtual tours. If they want to see, some parents wants to see the college, then they can go to this and they can visualize how a college looks like. Okay, so these are some applications of fully immersive environment. So there are some use cases like gaming, training and simulation, design and architecture, etc. etc. There are a lot of application which uses complete immersive AR VR. The next is non-immersive, where there is a limited interaction. So experience through some standard screens. Example is traditional games. So only in few things will be using this uh, virtual environment. So here in the immersive environments, it's a simple virtual world without full sensory immersion. So you can define non-immersive VR as a less advanced form of virtual reality where users interact with the virtual environment through a screen without being fully immersed. Okay. So example features are typically accessed on standard devices like computers or TVs. So normal devices are sufficient for this non-immersive. It does not require a headset or specialized equipment, limited user interaction with the virtual environment, etc. So example is some simulation games, architectural design and visualization tools, educational apps. These are some simple example for non-immersive, where very minimal virtual things are there. Mostly it is real data. Next comes the semi-immersive. It's a combination of both immersive and non-immersive. So here you have augmented reality where virtual elements overlaid onto real world scenes that we have seen already. Uh, Mixed reality, it's another kind where it blends both virtual and real world elements interactively and immersive. So it's a combination of both virtual and immersive and semi-immersive. Sorry, non-immersive. So it combines the elements of both immersive and non-immersive experiences, providing a middle of these two. Users can interact with the virtual environment, but they remain aware of their physical surroundings also. So, if in a complete immersive environment, we'll not aware of the physical surroundings, we'll be feeling that we are in the completely entire virtual environment. But here, you can interact with the virtual environment, like you can touch, feel, or you can move something, but still you can feel that you are in a some physical surroundings. So here you uses large screens, projectors, and or semi-enclosed setups. Here we need some devices like joysticks, touch screens for making this movements and all. So it provides a partial immersion using high quality visuals. So applications are like flight driving simulators, virtual classrooms, military simulations, etc. Again, these are different semi-immersive VR applications. Like you can use this in education for interactive learning experiences, retail, where you can visually see some virtual products, healthcare, where we can give some virtual therapies. As of doctors are here, they'll give some therapies, rehabilitation for the patients, etc. Now coming to elements of AR VR, so this AR and VR rely on several critical elements to create this immersive, interactive, and engaging experiences. So these are the different elements of AR VR. So first is so only if you have all these elements, then you will have that AR VR experience. So first is immersive display, where it provides visually engaging and lifelike experiences in AR VR environments. So display is important. Then motion tracking. So again, we have seen already. User movements has to be tracked like head, hand, body to enable interaction with the virtual environment. Then real-time rendering, it generates smooth and instantaneous visuals based on user actions. So if you move your hand, then if you want to move it, only if you shake or move your hand, then the virtual image or virtual things should also be moved. Then interaction interfaces, like it enables user interactions via gestures, voice, or haptic feedback. Like you can touch and you can give some feedback. You can give commands over voice. You can using your hand. You can show some gestures. So all these can be used to interact with the virtual environment. Next is spatial mapping. So this ensures accurate placement of virtual objects in the real world space. So here, as you know, in the AR and all, we have to place the virtual objects in the real world space. So we need some mapping of the actual real world space so that we can place the virtual objects in the accurately place the virtual objects in the real world space. The next is audio integration, where we need to integrate both sounds, directional and spatial sound effects. Then environmental integration, where we need to blend virtual elements seamlessly with the physical environment. Obviously, we need the support of AI. It adds intelligence for object recognition and realistic interactions. Okay, any doubts as of now in this? Shall we move on to the components of AR/VR, which is the topic of today?
Yes, ma'am.
Okay. So, in the components of AR/VR, obviously we need to create a fully functional and immersive virtual reality experience. So, For creating this, AR and VR relies on a combination of hardware, software, connectivity, and supporting technologies. So all these are important for creating a fully immersive or functional virtual reality experience. Okay, so now we are going to see about these different components. So first let's see about the hardware components. So if you see hardware, it is the backbone of VR systems, enabling users to interact with the virtual or augmented environment. So there are different hardware components available, which is the backbone, without which we cannot create the environment of virtual or augmented environment. Okay. So in that first one, very important one is head-mounted displays. So these are some of the examples of HMDs. So these HMDs help to display the virtual environment directly in front of the user's eye. Okay, so if you see, this is Oculus Quest, and this is HTC Vive, and this is PlayStation VR. Okay, so these are the headsets which helps or which is very much helpful for the users to view the virtual environment directly in front of the user's eyes. Okay, so we have to wear this head mounted displays, so which helps the users to view the virtual environment. So the features of this HMDs are like high resolution. So obviously resolution is very important, because the user has to feel that the user is in a completely different environment. So if it is not highly resolution images, then we may feel that it is not a real environment. Like in the virtual environment, we should feel that we are in that, we are living in that virtual environment. Okay, so that's more important. So resolution is very important in this HMDs. Then wild field of view, because here we are creating a different virtual environment where it should be the view should be wide and stereoscopic, because here we are creating a different virtual environment where it should be the view should be wide and stereoscopic 3D visuals. So obviously these things are important for head mounted displays. So there are a lot of displays available, HMDs available in the market. These are some of the famous HMDs which are available. Like this one is the first one, second one is Oculus Quest, and this black one is HTC Vive, and this white and black combination is PlayStation VR. So these are used, HMDs are used to view the environment. Next one is motion controllers. So in the, suppose if you are in the living real environment, we want to interact with the environment. Similarly, in the virtual environment also, we would like to interact with the VR environment, virtual environment. So for that we use handheld devices. So these are the bottommost three images shows the motion controllers are handheld devices. So they help the users to interact with the VR environment. So if you see here, there are buttons. Okay, so using which they interact with which they press the button. Sorry. So by moving this, by shaking this, they'll interact with the environment. For example, Oculus Touch, Valve Index controllers, etc. So these are examples. So they'll hold it in the hand, and if they move it, then automatically it interacts with the virtual environment. So here you'll have buttons, triggers, motion tracking sensors, etc. available. So using these motion controllers, users can interact with the virtual environment. Next comes the sensors and trackers. So obviously, using this, we need to detect the body movement, hand gestures. You can show some gestures to move, or you can call them back. So normally, when we talk with our friends or somebody, we will be using some gestures. So that can be incorporated in the virtual environment also. And head orientation. So by moving your head, you can give some input to the environment. So again, so for that we need sensors and trackers. So examples are base stations for HTC Vive, built-in cameras in Oculus headsets, etc. So see here, these are base stations, cameras in the headsets, etc. So they help to sense the environment and track the movement of the users who are using it. So the technology used are infrared accelerometers and gyroscopes here for tracking and the environment. The next most important device which is required for creating this virtual environment is this computing devices. So as you know, normally when we want to store image or audio or video, it takes a lot of memory and lot of processing capacity. For a simple image and video itself, it takes large memory space. But imagine we are creating a new virtual environment where we need to create lot of elements. So we for creating this, we need high performance computers, gaming consoles, standalone VR headsets, etc. So for that we need strong processing power to handle this real time rendering and data processing. So GPU is most preferable one for this AR VR processing. So this is another important hardware component required for this AR VR processing. Next is haptic devices. So they provide tactile feedback to simulate touch or vibrations. See, normally when we touch something, we'll have a feel. Similarly, using this gloves and all, these are tactile haptic devices. So when you touch something, you will feel that you are actually touching the element which are available present in the virtual environment. So the example you can see here, it's a virtual gloves, VR gloves, and these are haptic suits, Tesla suit, etc. So by wearing this, say this person he wears head-mounted display and also he wears this haptic devices. So by this, he'll visualize a virtual environment and also he moves his hand, shows some gestures, and he tries to capture some elements which are present in the virtual environment. So these five are the most important hardware components: head-mounted displays, motion controllers, sensors and trackers, computing devices, and the haptic devices. Next comes the software components. So the first important component is hardware. So obviously, when you want to work with the hardware, you need software. Without software, we cannot work. Okay, so software is crucial for generating virtual environments and enabling interactions in the environment. Okay, so we need a specialized software uh, for generating virtual environments and enabling interactions between the different elements present in the virtual environment. So if you take the different software components required are, one is game engines. Just a minute, I'll join in just in a minute. I'll join. Sorry, is it visible now? Hello?
Ma'am?
Is it visible?
Yes, ma'am. Yes, ma'am.
Okay. So, as we have started with the software components. Uh, so, first one is game engine. This is a platform which is used to develop and render AR/VR applications. So, examples are Unity, Unreal Engine, Fourier Studio, etc. So, these softwares helps to develop and render AR/VR applications. So, the features required for game engines are real-time rendering. Since rendering takes so much of time, we need this GPU, time and space. Okay, then physical simulation and environmental design tools. Then applications like the software which delivers specific AR/VR experience, example games, simulations, educational tools, healthcare, etc. So they deliver this required AR/VR experiences. Then next is content management system. They allow developers to organize and deliver virtual content because some without content like what is the game is about. If it is education, then say we can like for school students, if we teach science, then instead of teaching something theoretically, we can create an environment so that they can feel how different concepts works actually. And similarly, in healthcare, you can teach the students how to perform an operation using this AR/VR for different kinds. So for all this, we need some virtual content. So this content is also very important, which should be relevant to the environment or application which we are creating. So that's another software component which is essential for this. The next is operating systems. Obviously, it is core of any system. Without operating system, we cannot run anything. Even for any system, this OS is an essential one. So for this AR/VR, we have different operating systems. Like for VR, we have Oculus Runtime, Steam VR. And similarly, for AR, we have OS Arcade, AR Core. Yes, OS Arcade is for iOS and AR Core for Android. So they help to manage the hardware and software interactions. So first we saw about the hardware component. For making the hardware component to work, we need software components. So for that, we need game engines, different applications, then contents, operating systems, etc. And Unity and Unreal Engine are the most famous one, which are used for creating this AR/VR applications. Next comes the connectivity and communication. So for hardware and software to interact or to work together, we need this connectivity and communication. So for reliable, we need high-speed connections for seamless AR/VR experiences. So we need reliable connectivity, which ensures smooth interactions and synchronization between different AR/VR components. So for that, we need wired connections. So HDMI or USB cables, they connect headsets because head-mounted displays are there. So these connections are used to connect headsets to PCs or consoles for high-speed data transfer. So one is wired connections, another one is wireless technology where you need enabled untethered VR experiences. Example, Wi-Fi, Bluetooth, dedicated VR wireless adapters. So they help to connect wireless all the hardware components. Then cloud integration, where you need to store a lot of data, virtual data is to be stored. So obviously we need a cloud. If cloud is there, then it is beneficial because now every industry is moving towards cloud. So this VR content and user data can be stored and accessed via the cloud, reduces the hardware limitations. Otherwise, we need to have physical lot of high configured devices. So for storing all VR content and user data, because it occupies so much of space. So instead of investing more on hardware things, we can go for cloud integration. Then synchronization, where we need multiple sensors, controllers, and devices. All these have to work together seamlessly. So we need some system to synchronize different sensors, controllers, and devices, so that all these connect together and work seamlessly. Okay, so this is about connectivity and communication. Sorry, connectivity and communication. And next is key supporting technologies. So we saw about hardware, we saw about software, then connectivity. Then next is in addition to all these three, there are some important technologies which enhances the overall experience and makes AR VR as a more realistic one. So so these are the supporting technologies which are required. So first is artificial intelligence. Of course, now without AI, without machine learning, no application exists. Now it is introduced in almost all the applications. So AI is one of the most important things in AR VR also. So this AI is used for simulating intelligent virtual characters, automating interactions, and enhancing realism. So now you could have seen, many of you would have seen how different characters are created in games, and it looks like real characters. Uh, it plays with the human itself. So here now AI plays very important role in creating this virtual characters, and it automates interactions. When a user interacts, it automates it, and also it enhances realism. So for all this, AI is most helpful. Now AI is very much used in almost all kinds of industries. The next is 3D spatial audio. So it provides directional sound that matches the VR environment, meaning that we should hear from where the sound is coming. So either it should come from behind the user, or from left side or right side. So all this directional sound has to be matched. Example is hearing footsteps approaching from a specific direction. That is, say if you are walking and if you want to hear the sound of animal that can be heard from the behind us, and similarly you can hear the sound of a bird from top of us. So like that you can have this, you can fix that as using 3D spatial audio. That is, from which location, from which position we want to, from which direction we want to hear the sound. That's called 3D spatial audio. The next is haptics technology. That is, it simulates the physical sensation like touch, pressure, or vibrations. So the devices like gloves, suits, or controllers helps in simulating all this. Say if you touch something, you should feel that you are touching the actual object. Similarly, if you press an object, you should feel that you are pressing it. When you really pressing it, what feeling you have, the same thing you should observe. Just a minute. Sorry. Mm. Similarly, vibrations. So all this you should feel. So for that, the technology used is called haptics technology. So for that, we use gloves, suits, different controllers. And then next is advanced displays, where we use OLED, LCD screens for higher resolution and refresh rates. And eye tracking technology is also used, where based on our eye movement, this realism can be improved. Rendering and realism can be improved. Then environmental sensing, like SLAM, which we have seen already, for spatial awareness. That is the elements which are actually present in the physical environment. So that's another technology. Then because it helps the system to understand the user's physical space. Okay, so these are the key supporting technologies which are helpful in addition to hardware, software, and this connectivity and communication. So these four are the important components of AR VR, which helps in fully functional and immersive virtual reality experiences. And so these are in general, and there are some advancements in AR VR hardware and software. So if you take hardware, now improvement is there in display resolution, lighter headsets. The weight of the headset should be lighter. Otherwise, it is really difficult to wear it for a long time, and a more powerful process. So the processor capacity is improved. So these are some improvements, advancements which are happening in hardware. And then if you take software, then advanced rendering techniques, because rendering plays very important role, which makes the or which creates the actual virtual environment as the real one. Then real time interaction, that's another important improvement which is happening in software. Then intuitive user interfaces, so user interface experience, so that also improved in the software. And then another thing is cloud computing, where enhanced processing power and storage for complex VR experiences. So obviously, if you improve this hardware, software, etc., then the processing power required is also improving. So we need advancements in cloud computing also. And now we are in 5G era. So 5G networks are used for faster data speeds and lower latency for this seamless AR VR streaming. Otherwise, we'll have to wait for a long time to load a particular image or video, and we'll not have that feel of being in the virtual environment. So a lot of research is going on in all these components, hardware, software, etc., and advancements are happening in different things. So if you see, there is a growing trend in AR VR. A lot of rapid innovation is going on. Constant advancements are happening in hardware and software, and a lot of new use cases are coming in. New industries embracing VR applications, and the market is also growing like anything. Increased adoption and investment in VR technology. So in huge the AR VR application is growing in a huge way. So these are some of the common use cases for AR and VR. The industry are there are n number of industries where it can be used, like gaming and entertainment, where you will feel that immersive gaming experiences, and AR enhanced live events. Okay, so for that we use gaming and entertainment. Obviously, you know, healthcare, where applications in surgical training, patient education, and rehabilitation, we can use this healthcare. Similarly, if you take education and training, this AR VR simulations can be used for skill development and interactive learning. Say, for example, virtual labs, anatomy visualization, etc. This AR VR can be used in education and training. Similarly, if you take retail and e-commerce, you can sometimes you can try some virtually try if there is a dress, and you can virtually try if you wear the dress how you looks like. So that is possible with that. And similarly, you can have interactive shopping experiences, etc. If you take manufacturing and design, manufacturing industry, where you can create VR prototypes using this AR VR concept, and you can see equipment maintenance and troubleshooting using this AR VR concept. Uh, Similarly, there are different kind of use cases like military, defense, social interaction, agriculture, sports, etc., etc. So, if you see this AR and VR use cases span across different industries, enhancing experience of the different users, improving efficiency, and solving real world challenges through this immersive and interactive technologies. So as adoption grows, these innovations continue to redefine how we work, learn, and connect. So if you take retail, you can virtually try on interactive product demos, personalized shopping experiences. So all these are possible in retail industry. If you take healthcare, you can have surgical simulations, medical training, remote patient care, etc. Similarly, in education, you can have immersive learning environments, interactive textbooks, and virtual uh, field trips. So, if you go to a particular industry, how it looks like, how it can help education, all this can be possible. Similarly, in manufacturing, you can have training simulations. For simulations, it's very much useful because training in the actual environment would be very costlier. So instead, we can have simulations on the first hand. Then you can go for real environment. Then design visualization, remote maintenance support, etc. So these are some of the use cases and applications in across industries. So if you take surgical simulation, so first is some examples where AR VR can be used. So one is pre-operative planning. So it allows the surgeons to visualize complex procedures and practice surgical techniques before surgery. So we cannot practice on the real patient. So instead, the doctors, surgeons can visualize the different procedures just to be done before the surgery, and they can practice all the surgical techniques using this virtual environment before surgery. So once if they get used to it, then they can do the surgery in the actual patients. So we cannot actually practice on the real patients. So for that, this AR VR helps. Next is surgical training, where for new surgeons, virtual environments, they provide realistic training simulations so that it helps to reduce the errors and improves surgical outcomes. Then remote guidance. So experts can remotely guide surgeons during complex operations using AR overlays and real-time communication. Because some specialists will be available on different locations, they cannot directly come. Instead, they can guide the surgeons on complex operations using this help of AR. So the surgeons here, they feel that the actual specialist is present here, and they guide the surgeons who are actually doing the complex operations. Similarly, AR VR can be helpful in physical therapy. So one is pain management, where this VR, IR, VR can distract the patients from pain during therapy sessions, improving compliance and reducing stress. So they can visualize something else so that they can distract the patients. They'll not feel the pain. Normally, if you are in a pain, then our elders used to talk something. They used to distract us. The same concept is applied here. VR is used to distract the patients so that they'll not think about pain during the therapy sessions. Similarly, this AR/VR can be used for rehabilitation games. It allows for immersive and interactive rehabilitation games, motivating patients to complete the exercises. Then post-surgical recovery. So after surgery is over, again this VR therapy can help the patients to regain mobility and function after surgeries through personalized exercise programs. So for different applications, this AR VR is used. Similarly, this AR VR is helpful for patient education. It helps anatomy learning, where it allows patient to visualize their condition and understand their treatment plan in a clear and engaging way. So, many times patients will have a doubt what kind of treatment is happening, is it correct or not. So, maybe for educated patients, this can help what the treatment is actually going on. Next is pre-procedure preparation. So this VR simulations can help patients prepare for medical procedures, reducing anxiety and improving their understanding. So before going on, before appearing for any medical procedures, then patient can be prepared on what is going to happen, so that they'll understand this is what is going to be done. So we have to be prepared for that. So this ARVR can be helpful for pre-procedure preparation. Then again, it is helpful for post-procedure recovery also. Once the procedure is done, operation is done, so it helps some tutorials, resources, so that the patient recovers during the after the post-procedures. So we have seen some use cases on medical field. So how it helps. The impact of AR/VR on different industries. So obviously, it enhances the user experience. So simply viewing an image, it is if you see a virtual environment, definitely the experience of a user is enhanced. So that way, the users will get a very good experience. The new business models based on this AR/VR increase efficiency. So these are some of the impact of AR/VR on industries. So obviously, for any technology, there are some challenges and limitations. So for AR/VR also, there are challenges and limitations. Still, a lot of research is going on how to improve this AR/VR technology. So one obvious challenge is cost. Okay, so high cost of hardware and the software can limit the adoption of this AR/VR technology on day-to-day use cases, because we need specialized devices, specialized software, and you need high computing power, you need cloud, you need integrate 5G capacity. So all these are essential. So which makes the adoption limited. So that is the first, obviously the first challenge. Then second is content. So a lack of high quality AR/VR content hinders widespread adoption, because without the content there is no purpose or no meaning of using this AR/VR. So that's second limitation or challenges of using this AR/VR technology. So there are some specialist or AI technologies is required for creating high quality AR/VR content. Then next is usability. Some users they experience discomfort or motion sickness, because if they use this devices for a long time, then they'll feel discomfort. So that's another challenge. Then obviously privacy. So data privacy and security is a significant concern, especially with AR applications that map physical spaces, because real data is to be mapped. So that is again another concern with respect to AR/VR technology. So the future of AR/VR in healthcare, one is personalized medicine, remote healthcare, enhanced research. So this AR/VR can help personalized treatment plans based on individual patient needs and preferences. Remote healthcare, so even in from remote places, consultations and diagnostics can be done, expanding access to healthcare. Enhanced research, so AR/VR will facilitate new research methods, breakthrough in understanding and treating diseases. So AR/VR is helpful in most helpful in healthcare industry. So what will be the future of AR/VR? So it is shaping the future, offering exciting possibilities for entertainment, education, and beyond. So to conclude, you can say AR and VR are not just technologies of the future. They are shaping our present by revolutioning how we learn, work, and interact. By understanding their components and potential, we can better prepare to leverage these tools in meaningful ways. Thank you. I think I've completed.
Yes, ma'am. So participants, if you have any queries, so please ask. Ma'am, in chat box, one question is asked, ma'am. Ma'am, ma'am.
I think ma'am disconnected.
Yes, 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 ma'am. Just wait. So, dear professors, kindly wait. Some technical issue. Ma'am will connect within 2 minutes.
Okay. Can you hear me now?
Ma'am, yes, ma'am.
Yes, ma'am.
Ma'am,
Question was last because of
yes, ma'am.
data problem.
Okay, ma'am. Ma'am, the question I posted, ma'am, in the chat box.
See, haptics, how we can start to develop haptic devices. See, one is this developing haptic devices. What kind of feel we want to give, like whether we want to give touch or something like that. Then already there are a lot of haptic devices available. If you want to develop your own haptic devices, then it's uh, if you want to develop a device like gloves and all, then you have to consider all the different factors which is required. So based on that only you can develop. So it's not an easy thing. You should understand the different requirement for haptic devices. Then only we can do haptic devices. So what material to be used, what kind of sensors to be used. So all this you should analyze, and based on that only you can develop the haptic devices. First step to develop haptic devices. So haptic devices, again, as I've told you, what kind of feel you want to give through the haptic devices, that first you should understand. So for that you should know what kind of device you are going to develop, and what sensor is required. So all this you have to analyze, and based on that only you can you can decide what kind of haptic device to use. So already a lot of devices are available. You can try with that. If you want, then you can decide on which material to be used, so that you can have that feeling. So all this already available devices, you can do research, and based on that you can develop your own haptic devices.
Any other questions, please?
At least at this time, there are two questions.
Ma'am, Satishda, ma'am.
Yes, ma'am.
Okay, ma'am, we'll wind up. No problem.
Okay. I thank Shanti, ma'am, for sharing her knowledge with us. Thank you so much, ma'am. Thanks to all the participants.
I also thank the organizers and the participants for listening to this session. Thank you so much.
Thank you all. I will post the feedback link in the chat box. Kindly fill the feedback.
Thank you, Ma. Thank you, Satyasiva.
Thank you. Thank you so
Thank you.
much, ma'am.
Thank you so much, ma'am.
Thank you.